Welcome to the OpenTelemetry plus Cribl skill session. There's a ton of information in the space, and it's all a bit scattered. My goal here is to go over foundational concepts, but focus on practical information that's going to be relevant to you if you're working with OTel and Cribl. So quickly, I'm Emily Ashley. You may see my name around as MAsh, and I'm awesome. I'm going to zoom out first and talk about what OpenTelemetry is, the Spec and OTLP, signals like logs, metrics, and traces, and touch briefly on how SDKs work. And then how the OTel collector is used to send out that data. We'll take a look at some example protobuf payloads, collector configurations, and deployment patterns before moving on to the practical parts of how to use OTel and Cribl together with a special focus around batching, extraction, and conversion. So what is OpenTelemetry? OpenTelemetry can mean a lot of different things depending on who's talking, and we can get really pedantic. An overview would be that it is the APIs and SDKs, software development kit, which are standard interfaces for generating telemetry data. It's the OTLP and data models, which is a standard protocol that defines the shape of telemetry data and how it is transported. It's also semantic conventions, which are an effort around standardizing attribute names and meanings for telemetry. Collectively, all of those can be referred to as Spec. In addition to Spec, there's the OpenTelemetry collector. It's a software service to receive, process, and forward telemetry according to Spec. If you would like to join in on all of the pedantry around OpenTelemetry, the Linux Foundation has an awesome course called Getting Started with OpenTelemetry. As you know, the OpenTelemetry is an open source project under the Cloud Native Computing Foundation. So check out LFS 148. So what is OpenTelemetry Spec? OTLP defines how telemetry is encoded and transported using the OTel data model for logs, metrics, and traces. Now, in verbal conversation, I will rarely differentiate between the data model, Spec, and OTLP. So when I say OTLP conversationally, what I'm talking about is what a log, metric, or span looks like structurally, knowing that structure is primarily defined by the data model and the OTLP protobuf schemas, how those things are grouped and batched, and how they're serialized into protobuf and shipped over HTTP or gRPC. So what is protobuf? It's a schema-based data format from Google. You define structured data once, and then you can read and write it across many services and languages. So it defines messages in .proto files, like on the right, and then that data is serialized in a compact typed format, like on the bottom, which is a protobuf example, JSON-encoded protobuf. I'll touch more on this particular example of aggregation temporality and a protobuf definition later. What you do need to know is that with OTLP, there are two flavors of protobuf payloads. Binary protobuf, which is what most OTLP exporters send, and then JSON-encoded protobuf. Binary is smaller, faster, and the standard for OTLP. Humans can't read it easily, though. Goats can. For JSON-encoded, it's human-readable and easy to play with in tools that like JSON, but it's not what many OTLP receivers expect, including our OTel source. Protobuf schemas structure OpenTelemetry signals. For this particular workshop, we care about three OpenTelemetry signals: traces, which are made up of spans, metrics, and logs. There are other signals like baggage and newer ones like profiles, but I'm not going much into those here. However, while we are here, I will get you thinking on the nature of some of these fields. Here you see user ID or customer tier equals gold. You also see tenant name or US East as a region. Some of these are identity level, like ID or name, and some of these are segment level attributes, like tier or region. Some of these have a technical context, like tenant, and some of these have a business context, like customer. I also want you to think about which of these can only be gathered during an execution context or runtime, and which of these can be inferred or derived later. With these signals, I want to note something called context propagation as a foundational concept as well. And here comes my dev background. So traces. Traces are made up of spans. Spans in the OpenTelemetry data model have a trace ID, span ID, a parent span ID, a start time and end time to make up the duration, and attributes. Lots and lots of attributes. There's a blog post I like called A Practitioner's Guide to Wide Events on how to use some of these attributes. I also want to note here there are other fun things in the data model like span events or span length. So in tracing, when you initialize a trace, you start a span and give it a unique trace ID. You can use that trace ID to associate the subsequent calls and know they all belong to the same end-to-end request. Your span also has its own unique identifier, the span ID. The initial span of a trace has a span ID and a trace ID, but you will not find it has a parent ID. We'll call this the root span. Context propagation is then used to pass on the span ID to the next call, and that becomes the next span's parent ID. You can also pass along additional context, and there are formalized ways to do that with baggage. I know I said I wasn't going to talk about it, but here I am. So all this is propagated down through calls to different services and execution contexts that are all adding in attributes and context to the spans along the way. You can use the IDs and start and end times to create a waterfall view of how your system behaves. And this is the shortest tracing talk I've ever given because we have to move on now. So SDKs are part of OpenTelemetry, the software development kits. These technologies in the project help you create and emit these signals. You'll embed them in your applications. With an SDK in your app code, you can add a log with some context at specific lines of code. You can add a span as part of a trace. You can add a counter or other metric type. So there are all these fun ways to instrument your code using the SDK. You can create signals, modify, enrich them, and send them out. This all happens in the same execution context and timeline as your application as it's running. SDKs can be really powerful with a multitude of configuration options through environment variables and initializations within your applications. I cannot dive into that now, but it is so much and so cool. Check out this blog post we published on choosing between manual or auto instrumentation and how to figure out what's right. What you do need to know about the SDK is that there's something called a batch processor. The SDK creates logs, spans, and metrics in memory as your code runs, and a batch processor holds them and sends them out in batches instead of one at a time. You can configure your batch processor with settings like how many items to export, how long to wait before sending, or how long items can sit before being exported or dropped. So instead of, here's a log, send it, here's a log, send it, here's a log, it's more like, here's a batch of logs, here's a batch of spans, send them. So OTel SDKs can generate logs, metrics, and traces, batch them, and emit them directly from your application to any OTLP backend. Here's an example of one of those export requests. This one is a JSON encoded proto logs export request. As I mentioned, a JSON encoded proto is the more human readable one. Let's talk about this for a minute. When you look at the OTLP spec for something like logs, you'll see a structure of resource attributes, which is where the data was collected from using resource detectors. You'll see scope or instrumentation attributes, which is how it was collected, I'll say. And then there's a collection of log records, which are the individual logs. And you see here the log records, the log entries, right, have a body, attributes, severity info. They can also have a span and a trace ID on logs for cross-signal correlation, which is a workshop topic for another day. So you might have an OTLP log batch that has 3 logs all from the same resource, and another one from that same resource that has 100 logs in the log array, right? So here you'll see there's a log records array, and then each of these entries, there could be 3 of them, there could be 100 of them. What you need to know is that Cribl will receive this entire export request as one event. The same idea applies for spans and metrics. For traces in particular, keep in mind, batches are not typically organized by trace or trace ID. It's not, here's a trace and oh, it's neatly ordered for you. It's, here's the spans from this part of the system, and here's a bunch of spans we processed and are sending now that share common resource and scope attribute. So now that we've talked about OpenTelemetry Spec, let's move on to talk about the OpenTelemetry collector. The OpenTelemetry collector is a standalone component distinct from the SDKs. It offers a vendor-agnostic implementation for receiving, processing, and exporting telemetry data per OTLP specification. It's a component you'll run on your infrastructure. You can think of it as an agent on a machine, a sidecar to your application, or a gateway or proxy layer. Here's an example anatomy of an OTel collector config. It can receive OTLP from your instrumented apps, read from local log files or host metrics. It can do processing like batching, filtering, or attribute changes, just like I mentioned the batch processor in the SDK. It can export to multiple backends, and then the pipelines section will wire together the chain of receivers, processors, and exporters for each of your signal types. I do want to mention there are 2 different collector binaries. There's the OTel collector core, which is just OTel col. It's small, stable, and just the basics. There's also OTel collector contrib, which is the core plus a bunch of the fun stuff. A file log receiver, host metrics receiver, any of the Kubernetes stuff or vendor exporters will be included in that binary. There's also OpenTelemetry distributions, which are select binaries that people can create to grab and choose from the buffet of what they want in their OTel collector. Your config file components have to match the binary you've installed. If you put a file log receiver into the config, but you've only installed the core binary, the collector will fail to start with an unknown component error. It's a classic, why won't my collector start issue? So I didn't want you getting tripped up on that. So you can run the OpenTelemetry collector as an agent on a machine or a sidecar to your application. Here you can watch for logs and gather host metrics on that machine, receive signals from the SDK, and then process and forward those to an OTLP endpoint or backend downstream. A collector config for that might look like this. Here we have receivers for OTLP, which is from the SDK sending in, right? We also have a file log monitor and a host metrics, right? And we're sending those in their respective signal pipeline declarations and metrics and logs. In this example, I'm just exporting to debug for the sake of the workshop. You can also deploy collectors as a centralized gateway or proxy layer that many apps and collectors send to, potentially processing across multiple collectors or sending onward to multiple destinations. Here's an example of that kind of config. You'll see I'm adding a memory limiting processor, as well as changing the value of a resource attribute for a deployment environment, just for a little enrichment. Again, in my pipeline sections, I declare the processors and exporters I want to use. The collector can be very versatile. Here's a diagram from the OTel community of an example deployment. Here you can see collectors being used as agents, sidecars, and gateways, and even gathering metrics on how the gateway cluster is performing before sending on to multiple backends. Okay, that was a lot and very quick OTel primer. A little amuse-bouche for you. Now, hi, I work for Cribl, and there's a reason. OTel gives you well-structured, vendor-neutral telemetry, OTLP, semantic conventions, SDKs. SDKs and collectors are great at getting OTel out of apps and hosts, and a growing number of tools and data streams export OTLP. Cribl is 100% here for what happens after emit. And honestly, we're here even a little before that too. So this is a Cribl. Again, fastest overview ever. Cribl, Edge, Stream, and Search all have OTLP endpoints or receivers. We also have OTLP exporters, so you can send to multiple destinations or to data stores like Cribl Lake. Now you can start to see how adopting an open spec like OpenTelemetry can open up the possibilities for choice, flexibility, and control. In an ideal world, no one cares where the OTLP is coming from. Sending OTLP to Cribl, there are a couple of topologies. You can configure your SDK to go directly to Cribl's Stream, Edge, or Cribl's Search's Lakehouse engine. Just configure an OTLP exporter in your app's SDK to go to a Cribl OTel source. Or, if you want to use the OTel collector, you can send your SDK to the OTel collector, and then the collector's OTLP endpoint will point to a Cribl OTel source. I've also seen teams sending straight from the SDK to Edge, and then on to Stream. Cribl doesn't care where the OTLP is coming from. In all cases, you're configuring an exporter that sends batches of OTLP data to Cribl. What Cribl adds around OTel and friends. And here I say in friends, because when you're working with data, it's not all just going to be OTel. You're going to have varying sources for your logs. Here, we can have shared enrichment logic. We can attach business and infrastructure context where it makes sense, so every event carries the right story without extra overhead on your apps. You can have noise and safety controls. You can drop low-value events and redact or anonymize sensitive fields before data leaves your boundary. You can match data volume to usage, right? You can have higher fidelity in production systems, or implement sampling and low-value paths or non-production, like test or dev. You can use hot and cold storage, lake-first patterns, and send only what you need into expensive tools. And close to my heart, you can treat the pipeline like any other production system. It'll have owners, monitoring, version control, config as code, infra as code, right? And this can reduce the per team YAML drift in indifferent ways of doing routing, sampling, and enrichment. If the problem is, how do we govern lots of OTel endpoints and configs across orgs? We need a control plane, not just more collectors. Architecturally, decoupling collection from management provides the best of both worlds. Using an OTel collector with a very basic configuration, focused more on collection than any transformation or enrichment, allows users to separate agent management from telemetry platform or pipeline management. Aside from simply receiving the data from local sources, perhaps the only processing that should be in an agent OTel collector is adding the hard context that's near impossible to get later on. For example, Kubernetes pod ID. All the heavier processing, filtering, soft context enrichment, format conversion can be done later in the pipeline. This will reduce the compute load of the agent collector, which is good. because the agent shouldn't be stealing compute from the application it's monitoring. Also, OTel doesn't provide any kind of enterprise-grade fleet management, meaning that in all OTel collectors approach, your team may have to build an OTel control plane themselves, which is a significant undertaking. Using Cribl to ingest data directly from the agent collector should give teams enterprise-grade fleet management, perhaps with something like Edge, along with the ability to easily change how data is processed without requiring redeployment or downtime or a performance hit on your application infrastructure. As a side note, there was a fun CriblCon talk I need to find on using Edge to update local OTel collector configs, right? So really interesting use cases here on how to use something like Cribl hand in hand with OTel to manage the control plane of how your data is coming. With OTel handling instrumentation and Cribl as the data engine, you stay in control of the telemetry path. So how you prune, add, or scrub context, or even how you pick, combine, and adjust your tools, your routing, your storage strategies, or your data governance for your org, those can all change without having to re-instrument your services. All right, let's hook this baby up. Configuring an OTel source. For the sake of this example, I'm going to walk you through Cribl Stream and Cloud. If you are setting up OTel to go to Cribl Search's Lakehouse engine, Cribl Edge, or a self-hosted Cribl Stream instance, you may have some differences, so please reach out to your account team with any questions. If you're looking for easy ways to get sample data flowing, there is an OpenTelemetry demo, which is a telescope shop. I've used this and I have a config file for it ready in a OTLP GitHub repo. There's also telemetry generators you can use built into the OTel collector. Like here, there's telemetry gen. I have not used this, but it should be built right into your collector. Configuring an OTel collector. Here, I will define a new exporter. And you see I did a /Cribl on the name to give it a unique name. I will go ahead and add that to my log pipeline declaration as an exporter. Note that for HTTP exporter, the encoding JSON setting is unsupported as Cribl does not currently receive JSON encoded proto on our OTLP endpoint. So if you see that in your config and you can remove it, please do. Otherwise, you'll get a 501 not implemented error. Now we will define the endpoint we want our collector to send to. If you're wondering how to know what your endpoint is for Cribl, here is a breakdown. You have HTTP or S if you have TLS enabled on your OTel source in Cribl. You then have your worker group name, your workspace name, your organizational ID, which is that 3-word thing, .cribl.cloud, and the port. Now, when working with OpenTelemetry, port 4317 is typically used for gRPC and port 4318 for HTTP transmissions. However, port 4318 isn't available on Stream and Cribl Cloud at the moment, so you can pick an available port in the 20,000 to 20,010 range. Here, I have set it to port 2001. Now I want to mention something about signal-specific paths. You may see V1 logs, V1 metrics, etc. in some examples or documentation, and be wondering if or when you need those. For most HTTP exporters, if you give a generic endpoint, just the base URL and a port, the exporters will automatically append the correct path for each signal. So you generally do not need to manually add V1 logs or V1 metrics to the base endpoint. Where it gets tricky is custom overrides. For example, in collector configs, you can define a traces endpoint or a metrics endpoint. Those overrides are used verbatim. If you define them yourself, you must include the V1 logs or V1 metrics in those URLs for Cribl. If by chance you are using something that is not equipped as an OTLP HTTP exporter at all, like curl to test connectivity, you will also need to append those signal paths after the port. gRPC doesn't really function with signal paths. Routing happens with the service method on the gRPC service method. So if you are testing with curl and trying to understand endpoints and encoding requirements, I have a knowledge base article here. Also, I have a repo with a couple of utilities that can help. There's a curl command and a little Python script you can use to generate a binary protobuf log export for easy testing of your OTel source in Cribl. If you are sending SDK direct to Cribl OTel source, whether Edge or Stream, you can do that with an environment variable declarations of the endpoint. The same thing here on the signal-specific overrides and needing a signal path for Cribl. So if you see OTLP logs endpoint, you'll want to add the V1 logs. If it's just OTel exporter OTLP endpoint, the generic endpoint works. It'll add the signal paths for you. For Cribl Stream and Cloud, you'll go to configure a new OTel source. If you are new to Cribl, definitely recommend the new customer onboarding workshop to go through the fundamentals and learning your way around. You'll see some options here, and I want to talk through a few of them. Here you can see the OTLP version dropdown with options like 0.10 or 1.3.1. That setting doesn't need to match your emitter's exact minor or patch version. It just needs to be the right generation. Cribl uses it to decide which OTLP schema to normalize to internally and whether or not to expose the log endpoint. If that log endpoint is not exposed and you try to send logs into Cribl, you'll probably get an error message like, OTLP logs failed. Cribl returns unimplemented log service export. Why? Because of when logs became a stable signal in OTLP. We didn't build it out until it was ready. In collector configs, you'll usually see an HTTP or gRP exporter. Those go to ports 4318 or 4317, respectively. You may be wondering how to choose between HTTP and gRPC. My TLDR is that HTTP plays nicer, the load balancers, API gateways, and proxies you might already have in your architecture. But gRPC is faster and more efficient on the wire. So gRPC is great if your whole stack is already gRPC HTTP2 aware. But if not, there's nothing wrong with HTTP. Fun fact, with Cribl, you can technically set up your OTel source to listen for HTTP on 4317, but it goes against OTLP convention, so save that trick for a silly upside down day. A couple of gotchas. Port 4318 is unavailable on Cribl Cloud for Stream, so you'll need to use an available port in the 20,000 to 20,010 range. Here, I set it to 20,001. If you send JSON encoded protobuf to us, you'll get a 501. So there's also these extract toggles in your OTel source config for spans, metrics, and logs. Remember, OTLP comes in batches of events, and these toggles will allow you to work with the data on an event level within Cribl. We'll go into this much deeper in a moment, and they are super powerful. There are also auth and TLS options available. OTel auth is a hot topic on our roadmap right now, so definitely more to come this year. I am not a security engineer, but check out the great section in my previous OTel collector config about insecure skip verify true if you have a self-signed cert in Cribl Cloud. You'll see more on that in our OTel source docs. Worth noting that all of these options are source specific, so you may want to utilize multiple sources or worker groups depending on your versioning, protocol, and extraction needs. Unpacking OTLP batches, aka the extract toggle. Now let's really talk about the extract toggles in the OTel source. I've committed and deployed this with the extract disabled, and I've got my collector sending data into Cribl. With your live data, one export request might contain several groups of resource attributes, scope, and an array of end logs or spans or metric data points. If you don't extract, Cribl will treat each resource grouping as a single event. That looks like this. Remember the JSON proto example. If you pop that scope object open, who knows how many events are in there? You can see here how nested it gets and how it can be difficult to work with individual fields on batched OTLP payloads. To make that easier, we have a process called extract. When you extract, Cribl will take, say, a batch of 100 logs and turn that into 100 individual events that go through the pipeline. Each span becomes one Cribl event, right? It's nested under resource spans, scope spans. There's an array of however many spans. Each span will become one Cribl event. Each log in a log records array will become one Cribl event. With metrics, that goes down to the data points for each metric type. Each data point for some gauge or histogram becomes one Cribl event. Extraction logic iterates across all groups. For spans, we iterate all resource spans, scope spans, all the way down and emit one event per span, carrying the right resource and scope context with it. For metrics, go all the way down to the data points in the same way. This is powerful if you want to mask or redact at the event level, if you want to drop or filter specific events, enrich individual logs or spans, right? We have a lab, Optimization 3 Ways, for more information on this. If you're just doing pass-through on a particular signal or sending to storage where you don't really need to search it, you don't need extraction. If you're actually working on the data from that signal and pipelines, you do need to extract it. For logs and spans, when you toggle extraction, Cribl takes the batch's resource attributes and copies those attributes onto each extracted individual event. The same applies to the relevant scope attributes. Here you'll see they're all on the same level, which is different than the proto example we saw earlier. So after extraction, each log in Cribl has its own body, severity, IDs, etc., plus all the resource and scope attributes from the batch it was attached to. And it's attached directly to this event. That's great for processing because each event is self-contained and knows where it came from. And this is why all signals are extracted by default if you're sending to Search's Lakehouse engine. Here is the same thing on spans. But what this also means is those resource attributes are duplicated n number of times. If you had 100 spans, now you have 100 copies of the same resource attributes on each of those spans. So you can see data bloat from extraction if you send them out just like that. Don't panic. Don't panic. Don't panic. I'll talk later in detail about how to deduplicate, but just so you don't freak out in the meantime, the recommended pattern is that you extract logs or spans so you can work on them individually. You do your pipeline work, which is the masking, enrichment, aggregation, or dropping, and then you rebatch them using a pipeline function, metrics extraction. So metrics are a little special. When you enable extract metrics in the OTel source, on top of the extraction down to the data point, we also temporarily reshape OTLP metrics into Cribl metrics, our internal Cribl metric event format. Why? All of Cribl's metric-focused functions are designed to work on data that has been normalized into the Cribl metrics event format. So what does this mean? Similar to logs and spans, resource and scope attributes are copied down to each individual metric event, but we also flatten the structure. So in the pipeline UI, you'll see you get this nice metric view and syntax highlighting. And at the same time, we also attach an OTLP-aware object that keeps the original metric context, like aggregation temporality. That's why metric pipeline views do not look exactly like OTLP spec examples. They have flat pipeline and function-friendly shape that is ready to work. Quick UI tip. If you've got a mix of signals coming in, you can toggle between metric and event view like this. There is a lot to talk about metrics and all the things that can be done with our metrics functions like rollups and aggregations. But I'm going to say that's also an entirely separate workshop. So let's talk about OTLP in the pipeline. You've extracted the data. It's prepped and ready. Let's talk about what you can do with it. Okay, so quickly, in case you're new to a Cribl and what a pipeline is and how do you use one. Here you can see various pipelines. You can see some pre-processing pipelines, post-processing pipelines, as well as pipelines used in the routing table. Quick vocab. Functions are a piece of JavaScript code that executes on an event, and a pipeline is a series of those functions. You can read more about that on our doc site. Commonly used functions. I stole this from the tip sheet, which is highly recommended, obviously. Stream ships with a growing collection of highly configurable out-of-the-box functions. You can create, remove, update, and rename fields. You can add information to events like lookup and GeoIP. You can also find and replace using obfuscate, redact, hash with mask and eval. There are also functions for dropping events like drop, regex filter, sampling, suppress. You can change the shape of your data from structured and unstructured events with regex and extract, or parser, or with JSON flatten. There are also metric functions that can aggregate events in real time, like statistical aggregations, as well as converting events to metrics format with published metrics. So now that our data is in and extracted, let's do it. To work on a pipeline, my first step is usually to capture some sample data from LiveView. Here you'll see extracted OTLP, logs, metrics, and spans. Here I also was able to filter and just get the span. So if you see this OTLP type traces, you can get a sample of just spans or just logs using that filter, right? So here is that sample data. Let's talk about it. This is a decoded, normalized OTLP event as Cribl sees it in the pipeline. The structure is flattened with short, pipeline-friendly field names. You won't see those in the verbose proto-like definitions. Resource and scope attributes are copied down to the event level. There's a short definitions, right? And then for funsies, here are some span events in the wild. Span events are human-readable, discrete events during the span, i.e. credit card charge. But this leads to an important point. What extracted OTLP looks like inside of Cribl versus what it looks like when it's OTLP spec. So how exactly is this different? It's short form instead of long form key value pairs. The field names might be snake case or camel case. There are also internal fields like OTLP or Cribl metrics that say, treat me as OTLP logs, or treat me as metrics here, or what my fields mean. These help functions work with data in the pipelines. And again, those event level resource and scope attributes. I'm going to add a function to the pipeline, and you can see data in and data out and what has changed. So here I'm taking the start time and end time and creating the span's duration in milliseconds. For this one, I'm splitting the HTTP, path, and query for all server kind spans so that if they're doing searches on just what's in the query or wanting to aggregate based on what the base path is, that is easy to do. So here you see the URL query and the URL path broken into two distinct fields. After you do these modifications, enrichment, or redaction, you also want to use an OTLP function. What are they? OTLP functions, there's one for logs, there's ones for spans, and there's ones for metrics. It's 3 different functions. And what these do is they help work with our OTLP data and get them back into OTLP spec. So if you add the OTLP traces function to this pipeline where I calculated the duration and then split the path, here you'll see once I run this OTLP traces function with none of the settings enabled, just the function, you'll see here you'll get back to those long form key value pairs that are more true to the OTLP proto spec, right? Now we also have the ability to batch. We're going to rebatch so that we deduplicate those resource attributes. So here you'll see settings of batch timeout, like batch size limit, right? And we're going to turn this on and say, take all of these spans coming in and batch them back up into one payload event, right? One batch, resource batch event. And here you won't see any data. That's because you need to toggle the show dropped fields here. So now we have 2 logical groupings of the batches, and you'll see that if you pop these open, they have the same resource attributes, scope attributes, but inside they each have different spans. So this top group has 4 spans and the bottom group has 16 spans that are grouped together. And there you have the whole 20 spans that was in that sample that I created earlier. I'm going to go back for just a second to this view. So these will be closer to what we saw in the beginning of the workshop as far as those long form key values. If you send data out like this, you will see that data bloat I was talking about. I do want to note that putting it through this function, OTLP functions will ignore or strip fields that don't match the OTLP shape or internal mapping. They won't appear in the emitted OTLP payload. That again, if you add fields that don't map to any known OTLP field, like resource attributes, right? If you're not putting them in a drawer that is expected to be there, or if they're shaped in a way that the OTLP functions don't recognize as spec compliant, they will not be included in the emitted OTLP payload. So if you're enhancing OTLP data and pipelines, keep it spec compliant. Put things in resource attributes or attributes where OTLP expects there to be new data. Here you see the batched events. I made 2 batches, 4 and 16, it makes 20. So a debugging tip would be to run the OTLP functions without batching first. This is the easiest view to catch mistakes of where you may not have put things in OTLP compliant way. So you want to inspect individual events to make sure that fields are landing where you expect, that they're persisting through the function, not dropped or renamed unexpectedly. And if you think you've followed spec, but fields still disappear, that's a good time to open a support case and say, I followed OTLP spec, but this field is gone when I emit my OTLP, right? And then you can turn batching back on and do a spot check. Does it look right aggregated as an OTLP batch? And confirm once batched, the same fields show up in the correct places, right? So this is kind of like what that iteration looks like when you're building out a pipeline. Once you build those working pipelines, you can turn them into a pack for reuse. Also, a pro tip, if you don't know how to get to this advanced view, this is the quickest way to kind of iterate over those JavaScript expressions. You can pop this out in advanced mode and start working on the individual. You pick what sample event you want, right? And it tells you how it would evaluate the value expression, that JavaScript, on that sample file. That was a lot. So conversion use case. So if you're working natively with OTLP in and OTLP out, Cribl's internal or external representation usually isn't going to be a headache for you. But if your use case is doing conversion inside of Cribl, then you'll need to map incoming events into the short, flattened internal event representation, not directly to OTLP spec. So if you're doing like syslog to OTLP logs, a typical pattern would be running a parser to break out those syslog events, do an eval mapping to put them into the structure you want, and then an OTLP logs function to change those and batch those and send them out as OTLP. This is what that would look like. So here I'm running a parser function to take that raw event and make these individual structured field names. I take those structured field names and I map them to what it would look like as an OTLP log, including the resource attributes or scope attributes that we're going to need to batch them back up. I will note here that there's the option to keep or remove fields. You can remove the fields that you're not intending to use anymore, but if they're not OTLP spec anyway, you don't have to remove them in the step. Putting them through the OTLP logs function will remove them if they're not spec compliant, as I mentioned. So there's a little shortcut to doing less processing. You can leave the old fields in there and the function will remove them. So here we are adding attributes and a body, and then running it through the OTLP function will give them those long key value, form. And here we just turn on the batch, and here they are batched up, sending out an array of log records in OTLP spec that had originally come in as syslog. So where do you put things? This is where you can use the OpenTelemetry community data mapping spec as a guide. Be careful that the fields you add actually exist in the proto spec where you put them. And while it is generally best practice not to modify internal fields directly, this use case may require that secret nod and a wink of that, OTLP object. Here, I'll show you. That OTLP version 131 type logs extracted true. You may need that for this to correctly run through the function and batch them. So typically, you don't want to modify internal events, but if you were doing this conversion use case and the function isn't picking it up, try adding that little nod and wink to see if that picks it up. So aside from this, data model appendix example mappings, how do you know where to put things in conversion? I say to look to semantic conventions. A general take on logs is to put data and attributes when it's structured context about the event, but put it in body when it's the main log or message payload itself. On the metrics conversion side, if Cribl already recognizes events as metrics, you'll see the Cribl metrics fields present. You'll also see a little M indicator in the UI and that field highlighting, right? You'll get a metrics overview page for that pipeline, right? So if they are already coming in as Cribl metric format, you can run them through the OTLP metrics function to convert to OTLP and then send them out to OTLP compliant backends, right? Simple as that. Run them through the function there. If you have events that maybe should be metrics, but aren't showing as such, they don't have that syntax highlighting, right? Make sure there's a couple things you're going to do to convert them. Here, you want to make sure that all the fields you'd like to use in metrics are going to be top level fields. You also want to use the publish metrics function here, making them all top level fields. I'm like, hey, I want those dimensions. I want them up so I can use them. Then I'm going to use publish metrics and tell it how to extract the metric name, the metric value, and which fields are dimensions, right? And hot tip on this metric name expression, when you're looking at a metric view in Cribl, there is another UI toggle you can use to evaluate those metrics. If this is coming in verbatim as this JavaScript expression, try flipping that toggle to see what it's evaluated as. I can point that out another time. I want to note here that because metrics are flattened, when you're batching them back up, you will also need to find which fields become those resource attributes that we use in groupings, or that the downstream destination may use as labels, right? They might use resource attributes as labels. So here, there's the resource attribute prefixes array. That's where you'll put in, hey, from these metrics, from these individual metrics, these are the fields I want to group them by and bring up into resource attributes. So some of the fine print. Some OTLP backends have their own limitations of what they allow in the OTLP spec. These limitations are often configured with the OpenTelemetry collector as the neutral point of make sure to configure your OpenTelemetry SDK or collector to do X, Y, Z, or make sure your OTel collector has in setting turned on, right? So those same constraints apply when you're using Cribl as the OTLP emitter. We still have to satisfy the destination's expectations on what they allow in the OTLP spec. A big one that this comes up for is aggregation temporality on metrics. What is that? So aggregation temporality is how sums and counters are counted. They're either cumulative, right? Since beginning of time, this is how many ponies I've seen. Or they're delta. Since the last time I reported on ponies, I've seen 2 more ponies, right? Cumulative or delta. On the wire, that's going to be encoded as a number. 2 for delta, 1 for cumulative, or 0 for unspecified. When you're configuring an OTel collector, you'll configure it to say OTel exporter, OTLP metrics temporality preference. So that's what you'll see in downstream docs of what to set these based on their limitations. So here's a flashback to the protobuf. Here you can see on line 34 on the left, aggregation temporality 1, right? And here you can see on the right, there's that protobuf definition of what those different temporalities mean. So some OTLP backend will, drop or error on unspecified or cumulative sums and counters or histograms because they're going to require delta. So Dynatrace or Datadog. Some accept both, but strongly encourage delta for performance and ingest reasons, like New Relic. And others could be fundamentally cumulative systems, like Prometheus-style backends. So spotting and fixing this, a classic pattern would be if your gauges and histograms are showing up at your downstream endpoint, but your sums and counters are missing. Check to see if there's an aggregation temporality defined on those sums and counters, and compare that with destination's temporality requirements. If the destination docs call out an OTel collector SDK temporality settings, and you're doing OTLP metric conversion, which is a logs to metrics conversion, a spans to metrics conversion, and you can add a pipeline function to set it explicitly. Or you can add a post-processing pipeline to make sure all of the metrics that come through have a temporality defined. If things aren't showing up in your downstream destination, I want to recommend, I wrote this little utility of a collector receiver via ngrok. This is a vendor neutral way you can kind of set up a little endpoint on your system, point Cribl to it, and see what's coming in. So you can see better what Cribl is emitting and see like, oh, that other endpoint isn't receiving it, but my OTel collector is. There must be something different between the end destination and what an OTel collector can receive. Routing by signal in Cribl. So quick TLDR, there's a routing table. You write these input filters to decide what pipelines to send things to, and then where they go in a destination. Being explicit here makes it easier to know exactly which transformations each signal goes through. You can route data in part or in whole to several destinations, including data stores. For example, you could send traces with a subset of span attributes masked by a pipeline to one destination, but then also send a subset of those spans with full fidelity information unmasked to a different destination. Not a one-on-one routing topic, but an exciting use case to do. So you have all these signals coming into Cribl from an OTel source. Use a routing table to separate logs, metrics, and traces. I definitely recommend having those signals in separate pipelines. So in the routing tables, you can use JavaScript expressions to signify what to look for. Here is a case where I would recommend using those internal signal type fields that Cribl adds for OTLP events. That's the quickest way to separate them out. So here you'll say OTLP type equals metrics and make that a route, or OTLP type equals logs and make that a route, right? You can include any other context you want to use for routing, such as sending a subset of spans one place or transforming it differently for another place, right? There's lots of workshops to do around routing. It's a very common topic. Like, so why is this routing section only 2 slides? Routing is very cool and important, and there's just not that much OTel specific caveats to include. So this section is quite short for this workshop, but there's tons more you can learn about optimizing routing and what you can do with Cribl. So like, please sign up for the workshops, labs, skill sections. And with this volume of data, there's a lot to be said around ordering of filters and ordering of routes for performance. So don't sleep on the Cribl University sections on that. OTel destination, right? So how do you figure out where this data can go? There's a substantial list of vendors that natively support OTLP. There's 101 vendors on this list and counting. So some of these are going to be OTLP exporters, like a source, and some of them are going to be OTLP receivers, which is a destination. With destinations, it usually falls under 2 categories for how you're sending. You're either sending to a public OTLP, HTTP, or gRPC endpoint, so it's documented and you can point any OTLP exporter at them. Or it can be primarily collector agent-driven OTLP ingestion, right? So you're going to need an OTel collector with that vendor's distro to have that exporter on it. More and more vendors are creating OTLP intake endpoints. So that's cool for us because you can send directly there from Cribl without having to run any OTel collectors as a proxy to get those custom exporters. You can just point Cribl at the public OTLP endpoint. So of all of those 101 vendors and counting, if you look at our destination tiles, these match up with our destination tiles. I've made a non-comprehensive list about some of the endpoints we're going to talk about. When you're looking at these destination tiles, I want to note these destination tiles are only configured for using for OpenTelemetry if they say OTLP on them. All of the other ones are going to be like either the vendor specific or generic data type to send to those endpoints. If you want to configure OpenTelemetry to go to these vendors' OpenTelemetry endpoints, you're most likely going to be using this OpenTelemetry destination tile. There are also data stores to consider when talking about data tiering, right? So these are places you can send your OpenTelemetry data. You can also use Cribl Search and Cribl Search's Lakehouse, as well as Cribl Lake. There's a data tiering lab. I definitely recommend you sign up for it. Here's an example configuration of me sending my OTel demo data to go to Cribl Lake. And then here's a sample configuration of me running a scheduled search on that data lake of traces to have a tail sampling approach, sending just the amount of information that I want to send to my downstream system of analysis. If you remember at the beginning of the workshop, I talked a little bit about different categories of data, whether it's customer data or technical data, having that soft context or hard context. When working with observability data, I find there's a mix of business and technical context you needed in order to reach your organization's goals. So here you'll see I've written a tail-based sampler query, right? And it has some of the business context, such as the Strata is a premium customer, right? I want all of the traces, all of the spans from all of the traces, and I want all of the spans that have a premium customer associated with them. I'm going to get all of the traces that would include those spans, right? And then send those along. Same thing with the technical context. If I want them where it has an error or it has the status code, right? So you can layer these levels of importance of like, what is the high value data to you, and send just that while the rest of it stays in Lake. And then you can query that for what you need pending an investigation or pending an incident of like, oh, now I need all of the span from that endpoint, and then run another search for that. It's a very quick tail sampling. Could talk a whole nother workshop about what a stratified tail sampling approach would look like for working with tracing data. But here, all right, so back to how to configure destinations. Here's a non-comprehensive list about some of the endpoints you might be looking at. You can see there's a different kinds of ways they structure their endpoints, right? There's like beginning like X-ray and then your region and then ending with UN traces. Some of them, it's just like a gRPC endpoint, like api.honeycomb.io port 443, right? So here are just non-exhaustive list of some of the ways these endpoints might look. When you're going to configure them in Cribl, that's important to know what their documentation say about where their endpoint is. Here's an example of the Dynatrace OTLP destination in Cribl, which has some vendor-specific stuff, like which endpoint type, right? Which like auth token, all that is brought up into the top configuration because this is built just for Dynatrace OTLP. So here you'll see I've added that endpoint, right, based on their docs. Here's using the generic OTel destination to send to Honeycomb. So here I've done the same thing. I put the OTLP version, the protocol, and I've given that base endpoint that they need. I haven't done any endpoint overrides for the signal-specific paths because that's not needed for Honeycomb. But they do prefer an HTTP header to let you know which team you're sending to, right? So I've added that under extra headers in the advanced settings. Here's a good example of using signal endpoint overrides. This is for Splunk Observability Cloud. And here you can see I've added that traces endpoint override and that metrics endpoint override. Based on their docs, they have unique ways of defining those endpoints. So there you can put them in specifically verbatim based on their docs. I do want to add one more caveat about how the destination's live view works and what we are transmitting to those destinations. So our destination live view is before serialization to binary encoded protobuf. So it's going to be human readable, but it will not exactly match the full OTLP reference payload because some wrappers are added only at serialization time. So you won't see like a resource logs or resource spans wrapper when you're checking that data. If you want more information, like if you want to really test what is being sent, as I mentioned earlier, a really useful neutral test pattern is to run a local OTel collector with debug output going to a text file, and you put ngrok in front of it as a pub endpoint, and you can point your Cribl OTel destination at that ngrok URL. That's included in that repo I shared with you earlier. This lets you see how a vendor-neutral collector serializes Cribl's OTLP output and lets you debug basic structure and attributes and transmission of the OTLP pipeline before getting into the weeds of a vendor UI or integration or API limitations. On transmissions, I want to note that the logical batches you create in Cribl pipelines with the batch functions are not guaranteed to map one-to-one to network transmissions. The OTel destination tries to be performant, and that means it can send multiple logical batches in a single HTTP or gRPC call. So if you're hitting API limits on batch size or max payload size, rate limits, similar things on your destinations, it may not be enough just to look at the logical batch function. You might need to tune destination level knobs for max size per payload, max events per transmission, or possibly adjust the pipeline batching as well. If you're hitting strange destination-specific API errors I mentioned, too many points per payload or payload too large, too many batches per second, that's a good time to reach out to customer success or support, share examples, and we can figure out which knobs to turn. Here's that ngrok receiver code I mentioned. Awesome. So we did it. We covered all the things. You don't need me anymore. You are now an OTel and Cribl expert. Go on and be merry.